Now let's look at our concentration unit, molarity. Molarity is a very common unit for concentration for chemists. Molarity is defined as moles of solute per liter of solution. Notice that we use a capital M. Do not use a little m. Little m is used for meter. We always use a capital M for molarity. On how we read this, when molarity is an adjective, we're going to say 2.10 molar sodium hydroxide. So it is the molarity. It is a 2.1 molar solution. Let's look at an example problem. You're going to need to work a problem just like this in your experiment, and you will probably work some problems like this in the lecture part of the class as well. So on this kind of problem where you're given a molarity and you're not diluting a solution that already is made, you are making a solution from scratch, you don't want to use an equation for this. You want to approach this as a conversion factor problem. So approaching it as a conversion factor problem, the first thing we usually ask is what number do we start with in this first position here? And we usually want a number that's just one number and one unit. So it almost looks like we have two of those, and that's a problem. But what we need to know is that this molarity is really 2 units and 2 numbers. It is 2.10 moles of sodium hydroxide per liter of solution. 1 liter of solution. So we don't want to start with that number. That's 2 units. We want to start with the 50 milliliters of solution, which is just one number, 1 unit here. And then we know we'll put milliliters of solution down here, so it will cancel. What unit should I go to next? Well, maybe you figured out we're going to go to liters of solution next. The way that we know is that we've used that number. We know we're eventually going to want to use this molarity. And the molarity has liters of solution in it. So we can get to liters of solution, we can use molarity on the next step. So we need to fill this in. There are 1,000 milliliters in 1 liter. On the next step, I want liters of solution down here. We're following our usual pattern of canceling. Those cancel, and then these will cancel. And then what unit do I go to on top? Well, I said if I got to liters of solution, I could go to moles. So I'm going to put moles up here. And then I will fill in these numbers. The 2.10 goes with the moles per 1 liter of solution. So this step is our molarity step. Okay, so I might think I'm done because I've used all the numbers that were given. But if I stopped here, my answer would be in terms of moles of sodium hydroxide instead of grams. So I've got one more step. I need to go from moles of NaOH to grams of NaOH. Do you remember how we would do that? We're going to use the molar mass. The molar mass of sodium hydroxide. Remember, we look on the periodic table and we add up the numbers. Sodium's is 23. Oxygen's atomic weight is 16, and we have 1 for the hydrogen. That's 40 grams per mole for the molar mass. So when I use that in my conversion factor, the 40 needs to stay with the grams, and there's an implied 1 there. Okay, so if I punch this out on my calculator, my calculator says the answer is 4.2. But there's a problem with that. If you look at our significant figures, we need to have 3 sig figs in our answer because everything has 3. These are exact, of course. So to get 3 sig figs, my calculator doesn't know to add that 0. Very good. And just keep in mind, you could work the similar type of problem backwards. In other words, I could tell you how many grams of a solute you have, and you could figure out how many milliliters of a certain concentration of solution you could make. And we'll do that in my lecture for sure. But anyway, in lab, it's just like this, except instead of sodium hydroxide, you use sodium chloride. And the steps are the same.